Good evening, sir.
Good evening. How are you?
Fine, sir. How are you?
I'm also good. Thank you. Write this, okay? Write the products for the
Okay.
following. Akshay, I've got yours. Yeah, first one is correct. Second one is correct. Very good. Yeah, very good, Akshay. Very good. Waiting for others. Please send it fast. 2 more minutes. What happened, guys? Please send it. Hamza, Atif, Hiba. Kulsum, you joined a bit late, so take a bit more time, but please send the answers. Okay, Kulsum, no problem. Hamza and Hiba. Okay, Atif. Atif, please ask them again. Abhi, I think now it would have been uploaded because today's lecture will be uploaded tomorrow. Yesterday's lecture will be uploaded today. Okay. So it gets uploaded one day late. Okay. Hamza and Hiba, please send me whatever you have done. Hamza and Hiba. I don't know why you guys are not sending. अब मत भेजिएगा अभी. ठीक है. Write the products. CH3, CH2O, whole twice Mg plus H2 gas will be liberated. Here I will be having CH3O and thrice because Al is having 3 positive charge plus H2. Here I will be getting CH3, this part of carboxylic acid, C double bond O, and then I will write OCH3. Here also I will replace this chlorine with OCH3, CH3, C double bond O, OCH3. हमजा आप पढ़ाई नहीं कर रहे हैं. हमजा आप पढ़ाई नहीं कर रहे हैं, अगर आपने लास्ट क्लास को रिवाइज किया रहता तो ये दोनों आपका सही होता। ठीक है, सो प्लीज स्टार्ट रिवाइजिंग, ऐसे बिल्कुल खाली मत बैठिए प्लीज, अभी तो स्कूल वगैरह नहीं है आपका। चलिए राइट नेक्स्ट। हाँ, so in the last lecture we completed all the reactions that involved the cleavage of OH bond. Now we'll be looking at a different type of reaction in which you will write B type. Please write reactions involving cleavage of CO bond. Okay, involving the cleavage of CO bond. CO में ऐसे लिख लीजिए, COH bond लिख लीजिए, है ना, it will be better. This bond is getting broken. Okay, let us look at this bond here. We have here carbon and OH bond. Now this bond, if it is polar, as the polarity of this bond will increase, breaking this bond will be more and more easy, है ना। तो यहाँ पे जो आपके पास bond है, that is between carbon and oxygen, so you will write here higher the polarity between in लिख लीजिए आप in CO bond, easier it is to break the bond. Okay, now how will the polarity increase? Let us imagine we have different R groups here, है ना? So if I have only one R group, then this is giving electrons, है ना? This is giving electrons, and oxygen is getting more and more delta negative. If I add another, then the polarity here it will increase, and if I add another R group, this delta negative will also increase. Okay, so as I add different alkyl groups on the carbon of OH, that means alpha carbon, what is going to happen? The polarity is going to increase. The polarity is going to increase. Okay, so please write higher the polarity of CO bond, easier it is to break the bond. Then you will write as the number of alkyl group increases on the alpha carbon of alcohol, on the alpha carbon of alcohol, easier it gets to break the bond. Okay, easier it gets to break the bond. Okay, then you will write reactivity in the case of what? The cleavage of carbon and oxygen bond. 3 degree is most reactive, followed by 2 degree, and followed by 1 degree, and then followed by CH3OH. Okay, so this is the reactivity order for all the reactions that we are going to see now, for all the reactions. Okay, right next. लिख लिया आप लोगों ने ये सुनो, शय, आतिफ, हमजा, हिबा एंड कुलसुम, लिख लिया आप लोगों ने?
Yes, sir.
Okay. Great. Okay. Fine. Now you will write the first reaction. Reaction with hydrogen halides. We have already seen this reaction when we were doing haloalkane and halorine. So please write with me. Alcohols react with haloalkanes. Alcohol reacts with hydrogen halides to form haloalkane. Reactivity of HX towards alcohol. So HI is most reactive, followed by HBr, and followed by HCl. Why? Because HI can break easily. The bond between hydrogen and iodine is very long, so it is easier to break, and that's why iodine is present in a very good amount to do the reaction. Similarly, if I talk about the reactivity of alcohols, then here also 3 degrees was the fastest, followed by 2 degree, and then followed by 1 degree, and then followed by CH3OH. Okay, so write this down. Then write the reaction. You have ROH OH plus HX. Now here this bond breaks like this, and we get RX plus H2O. Okay, let me know if I have to scroll down. Sorry, if I have to scroll up. Now, write remarks. Due to lower reactivity of two degree and 1 degree alcohols with HCl, anhydrous ZnCl2 is used as a catalyst. Anhydrous ZnCl2 is used as a catalyst. Okay, so the reagent HCl plus ZnCl2, anhydrous ZnCl2, is known as dash. ठीक है, ये आप लोग को पता होना चाहिए कि रिएजेंट कौन सा है, इज नोन एज डैश. यू विल फिल दिस ब्लैंक. ओके, आप लोग देखिएगा हालोअल्कीन हालोरीन, उसमें हमने ये कराया हुआ है. ठीक है, द रिएजेंट HCl plus anhydrous ZnCl2 is known as dash. this reagent here, HCl plus ZnCl2. Okay, and then after that you will write देख के बताइए तो, can somebody please flip some pages and tell me what reagent name? देखते हैं आप लोगों ने कितना सही से नोट्स बनाया है, and how much do you guys revise also? It starts with L. The reagent's name, by the way. Yes, Akshay, correct. Waiting for others. We have done this ना Akshay in haloalkane halorine, वहीं से याद है ना आपको? Yes, Akshay.
Sir, you have discussed it. Yes, I didn't write.
Sorry.
So I don't know whether you wrote or not, but I've marked it in like rough. Maybe you discussed it.
नहीं, डिस्कस तो हमने किया है, लिखा भी है हमने, इतना भी हमको याद है. I've written this also. किया है, लिखा भी है. Yeah, Kulsum, correct. ठीक है, so this is known as Lucas reagent.
So can you scroll up? I got disconnected.
How much more? Atif, more?
No, sir. That's
Please take a screenshot.
yes, sir. I do.
Okay. Okay, the reagent HCl plus ZnCl, anhydrous ZnCl2 is known as Lucas reagent. It is known as what? Lucas reagent. What is Lucas reagent used for? Tell me. What is Lucas reagent used for? Please write. Lucas reagent is used for distinguishing between 1 degree, 2 degree, and 3 degree alcohols. 1 degree, 2 degree, and 3 degree alcohols. What happens? See, when we have this Lucas reagent, that means concentrated HCl and ZnCl2 and alcohols. These are all what? These are soluble. Okay. So alcohols and Lucas reagent are soluble, but chloroalkane is not. And hence it forms turbidity. So if you remember, I did this reactions in haloalkane halorine also. If I have 1 degree alcohol, then you need the Lucas reagent and heat to form turbidity. Okay, and heat to form turbidity. For 2 degree alcohols, you need to give Lucas reagent. It will form turbidity. in 5-10 minutes. No, you have to give it time. But 3-degree alcohol. Okay, so here, if you only give HCl and room temperature, you are going to get turbidity. Okay, immediately. Done, guys? Yes, no, please tell me.
Yes, sir.
Okay. Done? Done now? Okay, fine. I'll write some examples here. Okay, this is turbidin. Okay. For example, you also have okay. Write a note. Write a note here. 1-degree alcohol. 1-degree alcohol react with HX via SN2. Okay, 1-degree alcohol, they will react with HX via SN2. For example, if I have, let us see this reaction, CH3, CH2, OH, the presence of, let us say, HI is giving me CH3, CH2, I plus H2O. Now here the step 1 will be the HI, it will dissociate into H plus and I negative. Okay. Step 2, I will have this CH3OH, CH3, CH2OH plus H plus. This H plus will attack on the hydrogen here and it will get CH3. CH2 OH2, and the oxygen will get a positive charge. In step 3, I will have this I negative. It will react with CS3, CH2, and OH2 positive. This I negative will attack on this carbon atom. This OH2 will leave as water. So I will be getting CH3, CH2, and I negative. It is attaching on the carbon, so it is getting neutralized plus H2O. So these are the 3 steps which can happen if you have 1 degree alcohol, which have 1 degree alcohol. But for 2 degree and 3 degree, they undergo with SN1, and there can be some rearrangement because of the formation of carbocation. We'll look at it. Write these 3 steps. Am I audible, guys, properly?
Yes,
Hello?
sir.
Okay, thank you. Okay. Let me know if you're not. Next point. 2 degree and 3 degree alcohols. 2 degree and 3 degree alcohols react with HX via SN1, and hence quite often they give rearranged product. Okay, they give rearranged product. So as an example, we'll be doing one reaction, and that is also a, we'll show the mechanism of a reaction. That is also a question of the last question of this chapter. Okay, the last question of this chapter, it deals with the rearrangement here. So they're asking you that we have a reaction like this, in which we have CS3, carbon with CS3 and hydrogen, followed by a carbon, hydrogen. Here it has OH, and here it has CS3. Okay, and it gives the following product in the reaction with HBr. CS3 carbon, the Br gets attached in place of hydrogen here, and this is CS3. The next carbon, it has 2 hydrogen atoms, and then the CS3 atoms. They're asking why are we getting this type of product here. Okay, so we'll look at the mechanism. देखिए कार्बोकेटायन का rearrangement we have already studied haloalkane halide. So यहाँ पे हम एक like I will be doing this in a very concise manner. Please let me know if you don't understand it. Okay, then you will explain this, that this alcohol, I'm making it like this. Okay, 1 2 3 4 carbon atoms, 4 carbon atoms. This carbon atom, I'm showing this hydrogen here, and I'm showing this CH3 also here. Okay, similarly I am showing the OH atom here. Okay, now the first step is in the presence of H plus, right? Where I am getting this H plus from? I am getting this H plus from the HBr. What is going to happen? This oxygen atoms, lone pair electrons, they will attack on the H plus. Okay. Then here I will be getting OH2, and positive charge will be there on the oxygen atom. This hydrogen is here as it is, and this CH3 is also here as it is. Next step will be the leaving group will leave like this, and we will be forming a carbocation. So the carbocation will be formed here. The hydrogen is here. The CH3 is here. Now this hydrogen will do a rearrangement, which we know as 1,2 hydride shift. 1,2 hydride shift, and I will get the hydrogen here. Okay, and the CH3 is here. The positive charge will come here. And in the next step, what is going to happen? The Br negative attack on the carbocation, and I will get the Br on this carbon. CH3 is this. Please write this. Let me know if you have any doubt here. And important point is this from here to here. So you will show that this is 2 degree and this is 3 degree. This is more stable. This is less stable. And this is more stable. Done, guys. Jasola, please tell me.
Yes.
Okay.
No, sir.
Okay. Okay. Done. Okay. So right next, one more example. We saw 1,2 hydride shift, and now we will be seeing the 1,2 methyl shift. So if I have CH3 bonded to carbon, CH3, CH3, and it is having CH2OH. Okay, so this is what this is, neopentyl alcohol. Now it gives, when I react this with HBr, the product I should be getting that this OH should be replaced by Br. Okay, but no, I get some different product, that is CH3, carbon with CH3, CH2, CH3, and here I am getting a Br group. So as you can see, 1, 2, 3, 4, 5 carbons are here also, but again there is some rearrangement which has gone. So please write here. We have OH. This carbon is having one CH3 group, and there is also another CH3 group like this. Okay, the first reaction will be with H plus. Okay, the oxygen atom, lone pair will attack on the H plus, and we will be getting what? We will be getting OH2 with a positive charge on oxygen atom. this CH3 and this CH3 is as it is. Now this bond will break and we will be getting a carbocation, which is 1 degree carbocation. This carbon atom is here as it is, methyl group, this methyl group is as it is. And here is the carbocation that we are getting, which is 1 degree. Now there will be a rearrangement. Let me write CH3 like this. This CH3 will go here. And this is known as 1,2 methyl shift. Okay. 1, 2 methyl shift. Okay. And here we will be getting 1, 2, 3. And this carbon atom has got a CH3 group. There is already a CH3 group here. And here I will be getting a positive charge. Okay. Now this positive charge will get attacked by the Br negative. Okay. And I will be getting a product like this. Please write this down. This one here is 1 degree. This is 3 degree, right? This is less stable. This is more stable. Done, guys. Yes or no, please tell me. Please let me know when you're done.
Done, sir.
Anyone else who is still writing, please let me know. Okay. Right, next, reaction with phosphorus halides. This was the first reaction with hydrogen halides. Right, next, second one. Okay. Right. Various phosphorus halides. React with alcohol. To form haloalkane. Okay. So the general reactions will be something like this: ROH reacting with PX3. And they form here Rx plus POX3 plus HX. And you can have another, this is trihalide of phosphorus. If you have pentahalides of phosphorus, then it will be PX5, giving you alkyne halide plus H3PO3 I don't think it will give anything else, right? Now write some specific reaction. Let us take a molecule ethanol, CH3, CH2OH. Two, 3 and 4. Okay. Write the first reaction with PCl5. So what I will be getting here? CH3, CH2, Cl. PCl3 also same thing, CH3, CH2, Cl. If we do PBr3, I will be getting CH3, CH2Br, and if we have, let us say, PI3, we will be getting here CH3, CH2, and I. Rewrite some examples also. ठीक है, खुद से प्रोडक्ट लिख लीजिएगा, व्हाट्सएप में भेजने की जरूरत नहीं है. आई थिंक दिस आर इजी रिएक्शंस. Okay, I hope you have written these as following. So moving on. Right, next reaction with thionyl chloride. This is also we have done. Third reaction. Thionyl chloride. This is also we have done in haloalkane halorine, right? Please write with me. Alcohols react with SOCl2 to form chloroalkane. chloroalkane. And what do they form? Comma, SO2 and HCl. Write a general reaction, ROH plus SOCl2 is going to give me RCl plus SO2, which is going to escape, HCl, which is also going to escape. Write some examples. Ethanol plus SOCl2 is going to give you chloroethane plus SO2 and HCl. If you have some cyclo compound also, you react this with SOCl2, it is going to give me cyclo compound of haloalkane halorine. You'll write the side product as it is. And if you have something like this, let us see. Tell me. Write this down fast. Let me know when you're done. याद है ना ये रिएक्शन? ये सुनो, आतिफ, हमजा, हिबा, अक्षय, है ना? ठीक, जल्दी लिखिए. Okay. Reactions with thionyl chloride is preferred for the preparation of haloalkane. Why? Because the byproduct SO2 and chlorine, byproduct SO2 and HCl are formed. These are what? These are gases and they can easily escape. Done. Right, next, which is most important, acidic dehydration. कितना नंबर हो जाएगा ये? 4th number. Acidic dehydration. Acha. Acidic dehydration में you will write, first of all, alcohols undergo dehydration. Dehydration means removal of H2O. Okay. Alcohols, dehydration, yaad hai na? We have written this dehydration word in haloalkane halorine chapter, right? In the list of elimination reaction, we did dehydrohalogenation, dehalogenation, and then there was dehydration also. Okay. So alcohols undergo, this is a type of elimination reaction. Alcohols, they undergo dehydration, this removal of water to form alkenes. In the presence of a protic acid. Protic acid means an acid which is going to give you what? An acid which is going to give you H plus ion. है ना? Protic acid में example लिख लीजिए. For example, you will have H2SO4, no, H3PO4 also. Okay, what else you can use? Mainly these are only used. H2SO4 and H3PO4 are used generally. Okay, don't use HCl here because उससे फिर कुछ दूसरा reaction हो जाता है ना. HCl रखने से क्या हो सकता है? HCl रखने से haloalkane बन सकता है. That is why we use H2SO4 or H3PO4. In the presence of protic acid at 443 Kelvin temperature. This temperature is also important. Okay. So we have carbon. I have OH here, hydrogen here. In the presence of protic acid and heat, what is going to happen? This is going to get extracted and you are going to get water and alkene. एल्कीन में फिर याद रखेंगे कौन सा रूल लगता है एल्कीन में गाइस, प्लीज टेल मी कौन सा रूल लगता है एल्कीन में? अगर हमारे पास if you have any unsymmetrical alkene, then what is that rule? Z-Sev rule or Z-Sev rule, right? So you'll use that rule for unsymmetrical alkene whenever we have options of making double bond in more than one carbon atom, with more than one carbon atom. Okay. Done. We will look at mechanism then.
Done.
Okay, right, mechanism. Okay. Number one, we are looking at this reaction. Okay. CH2 double bond CH2 in the presence of, let us say, H2SO4 with some heat. It is going to, oh sorry, my bad. हमने alkene ही बना दिया पहले. Alcohol यहाँ पे होगा CH3 CH2OH. It is going to give me CH2 double bond CH2. Okay, plus water will be formed. Chali. Let us look at the step one. Right, step one, formation of protonated alcohol. This is the first step, formation of or protonation of alcohol. लिख लीजिए आप. Okay, right here. Plus H plus. Okay, now this oxygen atom will attack this H plus. We are going to get H. Like this. Step two. Now, as soon as we have formed, oxygen atom has got a positive charge. What is going to happen? It is going to leave, and water is going to come out as a leaving group, and you will be getting a carbocation, formation of carbocation. So I'm writing it like this now: CH3, CH2, OH2 positive. Now this bond will break, give the electron to oxygen atom, and here you are going to get a carbocation like this. H3C CH2 CH2 positive here. Okay. Now write the step three. Step three, what is going to happen? The elimination of proton. Okay, elimination of proton. I will have CH3 here. Single bond. Actually, यहाँ पे ऐसे हम. Let me show all the hydrogen atoms. Okay, now one of this hydrogen, it is going to break its bond. It is going to give the electrons here, leading to formation of alkene, that is ethene. H2 carbon double bond CH2 plus H positive. So whatever H positive was consumed here, it is getting out here. Okay, it is getting out here. Please write these three steps. An important thing is that, see, this is acid-base type of reaction. That is why it will be fast. Formation of carbocation is always going to be slow. Okay, Now this step is going to determine the rate of your reaction, and that is also going to determine the relative ease of dehydration, whether tertiary, secondary, or primary alcohol will be dehydrating more easily. So first of all, write this, then we'll write some conclusions. Then yes or no, please tell me.
Done, sir.
Done. Okay, write next. Write remarks. Number 1. Acidic dehydration of alcohols to alkene occurs via intermediate carbocation. Intermediate carbocation. And what is the stability of carbocation? Stability of carbocation follows the order. 3 degrees more stable, then 2 degree, and then 1 degree. Hence, the ease of dehydration also follows the same order. Okay, so if you have tertiary alcohol, 3 degree alcohol is going to get dehydrated most easily, followed by 2 degree alcohol, and then followed by 1 degree alcohol. Okay, right, next point. Since dehydration of 3 degree and 2 degree alcohols is easy, they are done at milder conditions. Okay, now you'll write it like this. 2-degree alcohol. So here, what do we require? Now, 2-degree alcohol can also be done in the presence of H3PO4. Okay, or it can be done. It can be done in H3PO4 also, like 85% H3PO4. You can remember it. And some milder temperature also. The temperature we require is 440 Kelvin. Okay, and I will be getting what? I will be getting only one alkene like this. If you have 3-degree alcohol like this, it just requires 20% of H3PO4, and it requires even milder condition, that is 358 Kelvin. And here I will be getting alkene like this. Only one alkene is possible till here. Let me know if you're done.
So is it 358?
Sorry, 358. Yeah, 358.
Okay.
Done? Yes or no? Please tell me.
Done.
Right, next. Dehydration of 2-degree and 3-degree alcohols always occur according to the Setzev's rule. According to the Setzev's rule. According to the Setzev's rule. So let me write some examples. Now here you will tell me, where should the alkene be formed? Here or here? Double bond कहाँ पे लगना चाहिए? Blue or green? 2 or 1? Tell me. First of all, you will identify what? First of all, you will identify the carbon containing OH group. Then you will see the adjacent carbon atoms. उसके बाद बताइएगा कि सातिफ correct. ठीक है? So the answer will be what? It will be on the second carbon atom. Correct, Akshay. Second carbon atom. Okay. Write some more questions. Write one more. राइट दी आंसर्स ना, चैट में लिख दीजिए डबल बॉन्ड जो होगा किस किस के बीच में होगा. ओके, अक्षय इज डन. सो आई होप यू आर गेटिंग आंसर्स लाइक दिस. कुछ लोगों का तो बिल्कुल जवाब ही नहीं आता कुछ भी. करेक्ट अक्षय. करेक्ट करेक्ट हमजा. Okay, right next. As dehydration occurs via carbocation, rearrangement can take place. Okay, so for example, if you have something like this, CH3, CH2, then again we have CH3, has a CH3 like this, and let us say we have OH atom here. Now, in this case, see what is going to happen first of all. Okay, so in the presence of acid, this will attack here, then it will form what? Then it will form OH2 positive. H2O will be removed, and I will be getting a carbocation like this. CH2 and a positive charge here. Okay, and a positive charge here. Now, this carbon atom here, it has CH3 group also, and here it has also hydrogen, right? Now, what this hydrogen can do, this hydrogen can get replaced here. It will do a shifting like this, and the CH2 will become CH3. Here we'll have the CH3 as it is with the positive charge here now. With the positive charge here now. Okay, now because see, this is 1 degree carbocation, this is 3 degree carbocation. So this transfer, the hydride shift will be what? Will be very fast here. Right? You can see that there is a hydride shift here. Now there is a positive charge here. It can either form a double bond with this carbon atom, which are same carbon atoms. There is no difference in those. And this carbon atom that is in the blue. So obviously you can see according to the ZZF rule or the ZZF rule, we will be forming the double bond here so that it has the maximum number of alkyl groups. Okay, so please write this down. Please let me know if you're done.
Done, sir.
Done. चलिए. See, the last example, एक और example लिख लीजिए जिसमें आपके पास मिथाइल शिफ्ट हो रहा होगा. ठीक है. Let's see if you have. Write another example. Let us see. Here you have CS3. Here also you have CS3. Here we have OH. So first step will be H plus, removal of water. Here I will be getting a positive charge. There is CS3 here also, and we have a CS3 here also. And this CS3 will be doing a shift. The CS3 has gone here now. The positive charge has been neutralized. Let us see that this CS3 is, I'm writing the CS3 here and a positive charge here, right? Now, since we have positive charge here, we can form a double bond here or here or here also, right? But we know that the blue one will be preferred because Z-zip rule. We have CS3 here, we have CS3 here, and double bond here. So here what we are showing? Here we are showing a methyl shift. Done, everyone? Yes or no? Please tell me. Yes. Okay. Right. Next, oxidation reactions, है ना? So ये कितना number reaction था हमारे पास? This was acidic dehydration, fourth, and fifth one, right? Oxidation. Fifth one is oxidation. ठीक है? Now, in oxidation, you will write write a point first of all. What are the different type of bond which are broken and what is the bond which is formed? We'll write that first. Okay. Please write the oxidation of alcohol. Oxidation of alcohol involves the cleavage of OH and CH bonds and formation of carbon oxygen double bond. है ना? As simple as that. We have carbon atom. It should have at least one hydrogen atom here. There will be oxygen, hydrogen. Okay. So what is going to happen? This bond is going to break. This bond is going to break. Okay, and here we will be writing carbon double bond O. Okay. So this one bond is formed, which is the pi bond. This pi bond is formed in oxidation reaction. Now, since here what are we removing? We are removing the hydrogen atoms. So it is also a kind of elimination reaction in which we are doing what? We are doing dehydrogenation. Okay, so please write. These reactions are also called dehydrogenation. Dehydrogenation reaction. Okay. Done, guys. Yes or no, please tell me.
Done, sir.
ठीक है, चलिए अब इसमें कैसे प्रोडक्ट बनेंगे कैसे प्रोडक्ट नहीं बनेंगे ये दो चीज पे डिपेंड करता है. ओके, सो द टाइप ऑफ अल्कोहल वी आर टेकिंग एंड द टाइप ऑफ ऑक्सीडाइजिंग एजेंट वी आर टेकिंग. ठीक है, तो ये लास्ट पॉइंट लिखते हैं फिर क्लास को खत्म करते हैं. दैट द फॉर्मेशन ऑफ प्रोडक्ट depends on the type of alcohol, 1 degree, 2 degree or 3 degree, and the oxidizing agent. Okay, let me stop this